The type of isomerism exhibited by the compound with the molecular formula C4H10O. These are the various types of isomerism given here: chain isomerism, position isomerism, functional and metamerism. So now we need to identify this particular compound exhibit which types of isomerism. So for that one, first we need to write down the various isomers possible for this compound with molecular formula C4H10O. Then only we can come to the final answer. First, let us check whether this particular compound is an aldehyde or not. Because whenever there is one oxygen atom in the organic compound, it can be an aldehyde. And if it's an aldehyde, definitely it can be a ketone. If it is not aldehyde and ketone, then we need to think whether it is an alcohol or not. So first let us check out whether it is an aldehyde or not. So these are the 4 carbon atoms of the compound, and one of them should be the aldehyde. And write down the hydrogens for satisfying the remaining valencies of carbon. This is the aldehyde with 4 carbons. What is its molecular formula? It is becoming C4H8O. So it is not satisfying the given formula C4H10O. So definitely the given organic compound is not an aldehyde. So definitely it cannot be even a ketone also. Now let us check out whether it can be an alcohol or not. Again let us write the 4 carbon atoms and an OH group. So I am writing the OH group on the first carbon and write down the hydrogens for satisfying the remaining valencies of carbon. So it becomes like this. And the molecular formula for this one is again C4 and hydrogens 3, 2, 5, 7, 9 and 10. So it is satisfying our formula C4H10O. So definitely that is an alcohol. So this is one of the isomer possible here, where the OH group is on the first carbon and the name of this compound becomes N-butyl alcohol. This is the common name. Let us write the other isomer of this particular compound. It is like this. We can write all the 4 carbon atoms connected to each other to form a straight chain, same as the first one. And now we can change the position of the OH group to the second carbon like this. And these are the hydrogens. So the name of this particular compound is secondary butyl alcohol. Then can you change the position further? Definitely no, because whenever 4 carbon atoms are there, we can write the position of the OH group either at the first carbon or at the second carbon only. Let's write the third structure, for which we need to change the arrangement of the carbon atoms in the carbon skeleton of the parent chain. So as we had written 4 carbon atoms in a straight chain here, let me write 3 carbon atoms in straight chain and 1 carbon present as a branch. And let me write OH group on this particular carbon. And these are the hydrogens. And 1 hydrogen here and 2 here. So it is CH3, CH3, CH2, OH. And the common name of this particular compound is isobutyl alcohol. Now again we can change the position of this OH group to the second carbon, because whenever this is the carbon skeleton, if you write the OH group here, here or here, it is the same compound. But when you write the OH group at this particular carbon, we get a different compound which is like this: CH3, C, CH3, CH3, OH. The name of this compound is tertiary butyl alcohol. And now tell me, is there any other alcohol possible for this particular organic compound? Definitely no, because we had written 4 carbon atoms in straight chain by changing the position of the OH group, and again 3 carbon atoms in straight chain and by changing the position of the OH group, and no other alcohol is possible for this particular compound. Then what is possible? You need to understand that alcohols and ethers are functional group isomers. So in ether there is an oxygen which is linked to minimum 1 carbon each, and as we are having 4 carbons here, I can write 2 carbons on each side to get this structure, then CH3, CH2, CH2, CH3, which is nothing but diethyl ether, or the IUPAC name becomes ethoxyethane. And the other alternative for ether is taking only one carbon on one side and 3 carbons on the other side, and these are the hydrogens, and this becomes methyl propyl ether, or the IUPAC name becomes methoxypropane. Means in this propane, on the first carbon there is a substituent which is nothing but methoxy. So the name of the compound is methoxypropane. And in this you can again change the position of the methoxy from the first carbon to the second carbon to get a different structure, and which is like this. So there is just only the change in position. So that is the reason why this becomes 2-methoxypropane, because now the methoxy group is on the second carbon, and of course the common name becomes methyl isopropyl ether. So for this particular organic compound, totally 7 isomers are possible and no other chances are there. Now let us check out what are the various types of isomerism exhibited by this compound. See here, N-butyl alcohol and secondary butyl alcohol, they differ only in the position of the OH group, isn't it? So definitely I can say that this compound is exhibiting position isomerism. Now when you compare structure 1 or 2 with 3 or 4, means 1 with 3, 1 with 4, or separately 2 compare with 3 or with 4. And these structures separately, they differ in the nature of the carbon skeleton, because here in both of them the carbon skeleton is 4 continuous carbons, but here it is only 3 carbons and 1 carbon present as a branch. So 1 and 2 with 3 and 4, they are the chain isomers because they differ in the nature of the carbon skeleton. And of course again 3 and 4 are position isomers. Why? Because both are having the same carbon skeleton, but they differ in the position of the OH group. So in this way, this organic compound is having 4 different structures which are alcohols. So it is having 4 alcoholic isomers, and this alcohol is a functional isomer of ether, isn't it? Diethyl ether, or all these 3 ethers, they are functional isomers with all these 4 alcohols, because both are having the same molecular formula but they differ in their functional group. So this compound is also exhibiting functional group isomerism. Position means the carbon skeleton is same, only the position of the functional group is different. And here in the case of chain isomerism, the arrangement of carbon atoms in the carbon skeleton is different. Then in functional isomerism, the entire functional group is changing. Then if you compare 5 and 6 or 5 and 7, in the case of fifth one, both the alkyl groups attached to the ether functional group are ethyl. So this becomes diethyl ether. But in the case of 6 and 7, one group is methyl group and the other group is propyl in general. That is N-propyl and isopropyl here. So the fifth one is different from 6th and 7th in the nature of the alkyl groups attached to the functional group. And what is this one? This is nothing but metamerism. The isomers which differ in the nature of alkyl groups attached to it, that is called as metamerism. So that is the reason why this compound also exhibit metamerism. So this compound of molecular formula C4H10O, it exists as 4 alcoholic isomers and 3 ether isomers, and exhibit all these 4 different types of isomerism. So our answer is option B.